Hi, this is Mallama. Now I would like to touch on a most general non-backtracking shift reduce parser called LR parser. It is based on the concept known as LR of K. L stands for left to right scan of the input, R stands for rightmost derivation in reverse, and K for number of look ahead symbols. K could be any value O here. For example, if K equals to 0, the corresponding parser is LR of 0. It's also known as SLR, that is simple LR parser. If K equals to 1, the corresponding parser is LR of 1. It's also known as canonical LR parser or CLR parser. Here there is one symbol of look ahead on the input. Now let us see LR parsing program in detail. And LR parsing program is common for all LR parsers. The input for the LR parsing program is string W we wish to parse, and a parsing table which is consisting of two parts. One is action and go to part. And output of the program is, if the string W is belonging to the given grammar G, then it produces rightmost derivation in reverse. It's also known as reduction steps of a bottom-up parser, otherwise an error indication. Initially the parser has S0, it is the initial state of the LR0 automata on stack, and input buffer contains the string we wish to parse and followed by the end marker $. Let A be the first symbol of the input buffer, and as long as the condition is true, we need to execute the body of the while loop. The action part of the table basically consisting of 4 possible entries. One is shift, one is reduce, and one more is accept, and last one is error. If it is shift, what the parser has to do, now we'll see. So if action of S, E, the parser has to consult the action part of the table. If the particular entry in the action part of the table is shift of T is the new state, the parser has to execute 2 different steps. The first step is to push the new state T onto the stack and let A be the next input symbol. If it is a reduce entry and reduce it by using the production A to beta, then parser has to execute the following steps. First, to pop length of beta many symbols of the stack. Let state T now be on top of the stack. Push go to of T, A onto the stack and output the production A to beta. Else if action of S, A equals to accept, then break, else call error recovery routine. Now let us see glimpse of the above program. If the particular entry is shift of T, the parser has to execute 2 different steps. The first one is to push the new state T onto the stack, and it has to advance the input pointer 1 position towards right to process the next input symbol of the input buffer. If at all the particular entry is reduced by using the production A to beta, the first step the parser has to do is output the production A to beta, then calculate the length of the beta, that is RHS of the production, and pop those many states from the stack, then find out to go to of T, which is the state which appears on top of the stack after popping length of beta many symbols from the stack, A. A is the LHS of the production we wanted to reduce. Suppose it gives us a new state, say P, then push the state P onto the stack. If it is accept, the parser has to announce acceptance of the input, that is the successful parsing, that is parsing is done, else the parser has to call an appropriate error recovery routine. Now let us see an example based on the program what we have discussed. Consider the grammar. It is an arithmetic expression grammar: E to E plus T, E to T, T to T star F, T to F, F to E within the parenthesis, and F to ID. And the parsing program is ready, which has 2 parts. One is action part of the table and go to part of the table. The behavior of the parser can be described through set of configurations. Each configuration gives us the current stack contents and the current content of the input buffer. Let us see what is the first configuration of the parser. Suppose 0 is the state which is on top of the stack and the current symbol to be processed is IG. The parser has to consult the action part of the table for the particular entry. Action of 0, ID. Action of 0, ID is S5. So the parser has to push state 5 onto the stack and advance the input pointer one position towards right, and the corresponding action is shift. Now state 5 is on top of the stack and the next input symbol to be processed is star. The parser has to consult the action part of the table for the entry action of 5, star. It is R6. The production number 6 is F2 ID. So it has to output the production F2 ID. The length of RHS is 1. So it has to pop one state from the stack. After popping state 5 from the stack, the state which appears on top of the stack is 0. Now find out go to of 0, F. It is 3. So the parser has to push state 3 onto the stack. This is the new configuration after executing reduction step. Now state 3 is on top of the stack and the string symbol to be processed is star. So parser has to consult action part of the table for the particular entry action of 3, star, which is R4. R4 is T to F. So it has to output the production T to F. The length of RHS is 1 and pop top of the stack, that is 3. Now state 0 is on top of the stack. Find out go to of 0, T. 0, T is 2. So the parser has to push state 2 onto the stack. This is the next configuration. Now state 2 is on top of the stack. The parser has to consult the action part of the table for the particular entry action of 2, star, which is S7. So it has to push new state 7 onto the stack and advance the input pointer one position towards right, and the particular action is shift. Now state 7 is on top of the stack and the symbol to be processed is IT, and find out action of 7, IT. Action of 7, ID is S5. So the parser has to push state 5 onto the stack and advance the input pointer one position towards right, and the action is shift. Now this is the next configuration of the stack as well as input buffer. Once again the parser has to consult action part of the table for the particular entry action of 5, plus, which is R6. R6 is once again F2 ID. So it has to output the production F2 ID. The length of RHS is 1. So pop one state from the stack. After popping state 5 from the stack, the state which appears on top of the stack is 7. It has to find out go to of 7, F. Go to of 7, F is 10. So it has to push state 10 onto the stack. These are the new configurations of the stack as well as input respectively. Now state 10 is on top of the stack and the next input symbol to be processed is plus. The parser has to consult action part of the table for the particular entry action of 10, plus. 10, plus is R3. R3 is T to T star F. So it has to output the production T to T star F. The length of RHS is 3. So it has to pop 3 states from the stack, that is 10, 7 and 2. The state which appears on top of the stack is 0. Find out go to of 0, T. 0, T is 2. So it has to push state 2 onto the stack. This is the next configuration. Now once again consult action part of the table for the particular entry action of 2, plus, which is R2. R2 is E to T. So it has to output the production E to T. The length of RHS is 1. So pop one state, that is 2 from the stack. Now state which appears on top of the stack is 0. Find out go to of 0, E. 0, E is 1. So push state 1 onto the stack. This is the next configuration of the stack as well as input buffer respectively. The parser has to consult action part of the table for the particular entry action of 1, plus. 1, plus is S6. So it has to push state 6 onto the stack. Now this is the next configuration of the parser, and similarly advance the input pointer one position towards right. So the next symbol to be processed is ID. This is the next configuration of stack and input buffer respectively. Now the state 6 is on top of the stack and the symbol to be processed is ID. Consult action part of the table for the particular entry action of 6, ID. It is S5. So it has to push state 5 onto the stack and advance the input pointer one position towards right, and the action is shift. And this is the new configuration of stack and input buffer respectively. Now state 5 is on top of the stack and the next symbol to be processed is $. It has to consult action part of the table for the particular entry action of 5, $, which is R6. R6 is F to ID. So output the production F to ID and the length of RHS is 1. So pop state 5 from the stack. The state which appears on top of the stack is 6. Find out go to of 6 comma F. 6 comma F is 3. So push state 3 onto the stack. This is the next configuration of the stack and input buffer respectively. And the action is reduce F to ID. Now the state which is present on top of the stack is 3 and the next symbol to be processed is $. Consult action part of the table for the particular entry action of 3 comma $, which is 3 comma $, is R4. So R4 is T to F. So output the production T to F. Length of RHS is 1. So pop one state from the stack, that is 3. Now state which appears on top of the stack is 6. Find out go to of 6 comma T. 6 comma T is 9. Now push state 9 onto the stack, and this is the current configuration of the stack and input buffer respectively. Now once again the parser has to consult action part of the table for the particular entry action of 9 comma $, which is R1. R1 is E to E plus T. So output the production E to E plus T and length of RHS is 3. So pop 3 states from the stack, that is 9, 3 and 1. Now state 0 appears on top of the stack and consult go to of 0 comma E, which is 1. So the parser has to push state number 1 onto the stack. Next, this is a new configuration of stack and input buffer respectively. Once again, it has to consult action part of the table for the particular entry action of 1 comma $, which is accept. So action is accept, that is the parser has to break with the success and it has to announce acceptance of the input. Thank you.